my God, the sun is shutting down. Stop the presses, folks. Stop the presses. It's time to hide in your bunker. We'll tell you all about it here at the Smash News Network. Least busted name in news. Make sure your bunker is just the right depth, folks. Just the right depth. We're looking at the sun here in ionized carbon. That's 1600 angstroms wavelength. And oh noes, we've seen another solar downtick since yesterday. Does it mean it's a grand solar minimum? Well, absolutely not. What it means is that we are fixing to see a huge uptick. We'll tell you why later in the video. That's a 24-hour video from the SDO, the Solar Dynamics Observatory. And by the way, thanks for tuning in to the Daily Space Weather. Congratulations on realizing that the channel exists. So here are some more exciting looking wavelengths. 304 plus 211 angstroms. And you may notice some activity there, a crown prominence around the north heliographic polar region, also a well-defined coronal hole there, moving right into the Earth-facing zone. That dark feature there right in the center. And also some filaments. We'll get to them later in the video. Let's take a brief trip around the horn first. Here is your northeastern limb. By the way, this active region over here is not yet a sunspot. So far, we only see some magnetic field organization there known as a plage. Not a sunspot, at least not yet. It could turn into one. But when we did show prep, it wasn't. Let's take a look at that crown prominence. You may see all kinds of imagery of that all over the internet today. We've got a great Earth scale image there. Yesterday it looked like a dancing stick man. Today it looks like a dancing Christmas tree. That's, by the way, 304 plus 211 angstroms for the past 24 hours. Ionized helium plus iron. It's a heavy metal star, folks. A heavy metal star. Continuing on, here is the zoom out to the northwestern limb. Again, we've seen a decrease in activity since yesterday, so we'll talk about a dip in the radio flux and the sunspot number and so forth, and why you can expect a rapid uptick in the coming weeks. There's your southwestern limb, and we'll also briefly show the southeastern limb. This rising active region over here is likely a sunspot. We see quite a bit of material there, and it's looking like some activity. So you see that material bubbling around, looking a little bit unsettled, an indication that it is indeed a sunspot about to rise there in the southeast. Let's take a look at sunspots there as yesterday plus today, and a further decline in sunspot number here. We've got some evaporating sunspots, especially in the southern hemisphere, also in the northern hemisphere. Lots of sunspots going away. Here's your colorized magnetogram for the same period. That is yesterday plus today. March 15th plus March 16th. And we did have a major earthquake. Let's take a look at volcanoes first, as many of our viewers would want us to do. So here's Popocatépetl, producing some incandescent lava there, lighting up the low clouds that are just above the caldera. Great imagery from webcamsmexico.com there of Popocatépetl. And let's see what else is erupting. Shivaluch is indeed producing a 13,000-foot ash plume over Kamchatka as it explodes, flight level 130. Subinosejima, flight level 050, 5,000-foot ash plume. Semeru, exploding, flight level 140, 14,000-foot ash plume. 20,000-foot ash plume from Popocatépetl there. It's a flight level 200 over central Mexico. Santiaguito in Guatemala also exploding, flight level 140, flight level 170 over Fuego. as Fuego explodes. Nevado de Ruiz also exploding. Flight level 230, flight level 200 over Sangay in Ecuador. Also Revenador in that same nation, producing a 14,000-foot plume of volcanic ash. Please do not pole vault the caldera. Also intermittent puffs from Sabancaya, a reminder that it is still active in Peru. Next, looking at seismicity, and we did have a 7-magnitude quake. That occurred at the Kermadec Trench there, in between Tonga and New Zealand. That is the location of that quake. That came in at 00:56 Universal Time this morning. And if you're wondering if it produced any tsunamis, I don't think so. Not according to tsunami.gov. We don't think it produced any tsunamis, and we didn't send out any email alerts about that at smashamash.com/smashteam. Anyway, let's see what else has been erupting here over the past 24. We'll cite quakes over a 5 magnitude. And by the way, for all those channels out there who are attempting to forecast earthquakes via the ionosphere, please do. It's part of the reason why we show the ionosphere every day, because people claim they can forecast earthquakes. We just don't see them actually forecasting earthquakes. Something that you would expect them to do, not only for the betterment of mankind, but for the betterment of their own YouTube channels. So, we did see a 5.4 at the Philippines. That happened at 21:25 Universal Time yesterday evening. And then, pretty much without warning, a 7.0 strikes the Kermadec Islands region. Of course, not a lot of people around there. Probably not felt by too many humans, that 7.0. It's a pretty desolate part of the world indeed. The southwestern Pacific. And no surprise, we saw at least one 5-magnitude aftershock there, right in the same location. There was also a 5.2 at Indonesia. That one northwest of Australia. And that's where we'll end our earthquake coverage and get back to space. Here's the past 24 hours in SDO 304 angstroms. One of the many favorite wavelengths. Of course, it's classic ball of fire color scheme there. Of course, if we made it look blue, people would think it looks like a ball of ice. Keep in mind, this is the ultraviolet wavelength. Part of the ultraviolet spectrum there, the extreme ultraviolet spectrum, the upper level of ultraviolet light. Not visible to the naked eye and not even visible at ground level. It needs to be viewed from space, as those frequencies are filtered out by Earth's mesosphere. By the way, if you want to support the channel, visit the links below the video. One of the links you'll find is to a Redbubble shop. The products there will be in order of best selling. Today's featured product is something you may have seen lots of on the internet: shartlighting. Yeah, shartlighting. Shartlighting is when somebody attempts to gaslight you and then fails and basically craps on their own credibility. Imagine lighting a fart and accidentally crapping on your hand and the lighter. That is the metaphor of what shartlighting is. Shartlighting. When somebody fails to gaslight you, especially on social media, or perhaps, on a YouTube video or something like that. Lots of gaslighting being successful. Gaslighting is a psychological abuse visited on people when folks try to make you remember a false recollection of reality. So lots of shartlighting on YouTube, lots of shartlighting on Facebook, Twitter, etc. Lots of shartlighting by bureaucrats going on in the past, say, 3 years. As remember, folks, just yesterday was the 3-year anniversary of an apparently engineered market crash. Yeah, the March 15th, 2020 mysterious market crash. Anyway, thanks for leaving comments, Mr. Bordages. So don't be gaslit, and make sure you tell your friends and foes when they fail to gaslight you that they've shartlit, instead crapping on their own credibility. Getting back to space, here we've added 171 angstroms to the 304 angstroms ionized helium wavelength. That's a great composite also. We've got plenty. fact, today we'll be featuring lots of 171 angstroms wavelengths. Most of our imagery will include the house favorite wavelength. Anyway, the 10.7 centimeter radial flux has dropped all the way down to 136 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 joules of radial flux density. And if you're wondering where the radial flux comes from, it comes from right around here, the upper chromosphere and lower corona. There's the one-year graph to put that in context, and again, you can expect to see a massive uptick in this coming. We'll tell you why when we talk about coronal holes. First, some additional information here. Again, that's the one-year chart of the radial flux, which is represented by this black line. The red line below it is the sunspot number. The blue line below that is the AP, which is just an average of Earth's geomagnetic indices. And here's our space weather enthusiast dashboard. It looks like things are subsiding, although we do still see a coronal hole high-speed stream striking Earth's magnetosphere. We got up to just about to KP6 twice in the past 24 hours. We'll tell you why in a moment. First, let's take a look at Earth's magnetic moment from space. So these are the past 4 hours. Pay attention to the time and date stamps. You can see them in the upper right. So things are pretty steady here. Again, we do have a coronal hole high-speed stream currently striking. So that is going to increase the pressure there a bit. That's magnetohydrodynamic pressure in nanopascals. Here are ground magnetic perturbations. And by the way, we sent out email alerts last night about the sudden pulse of the coronal mass ejection arrival. It showed up a little bit earlier than expected, but pretty much right on time. So that was interesting. That's the past 4 hours of Earth's magnetic moment from the ground magnetic perturbations, magnetic flux density. So here is the KP index. KP stands for, the K index on a planetary scale, a general measurement of Earth's geomagnetism. So 2 points we reached 5.67. Of course, this is the CME arrival there. It happened during a coronal hole high-speed stream, and the leading part of it included a strong negative BZ signal in the magnetic field associated with the solar plasma. Since then, it has subsided. Current conditions are only 1.33 for the planetary K index. And let's take a look at the solar wind measurements located at Lagrange 1. And here we go. There is your real-time solar wind. Current conditions are about 10.5. I'll say about 10 protons per cubic centimeter. That's a solar wind density. Solar wind velocity here still over 500 kilometers per second. And let's just illustrate the arrival of the coronal mass ejection. So the coronal mass ejection impact was right here. Its magnetic field arrived first, and since then it has largely subsided. So right in here you can see this. This is the strong BZ that I talked about. We had a total field strength of it got all the way up to 14 nanotesla with a negative BZ of negative 12. So that's what caused your KP6 conditions. It quickly subsided as the magnetic field's vertical component swung back into positive territory, and then only flirted with negative BZs. So it was just a minor coronal mass ejection impact. Another example of how we tend to over-forecast instead of under-forecast. So anyway, the density made it up to just about 20 protons per cubic centimeter. The speed was doped up to about 580 kilometers per second there, but only for a brief period, about 590 actually. And then you can see this plasma temperature returning to the signal that it was at before. So that's an indication that the coronal mass ejection has subsided, and we're just back to a high-speed coronal hole wind stream. Continuing on to our GOES magnetometers, there you go. That's the past 3 days. You see some spiky readings happening there around noon local time, actually. So we saw a pretty weak field at noon local time for the GOES 16 and a much stronger field for the GOES 18. So despite them being at fairly similar locations there, noontime for the GOES 18 had a strong magnetic field, and the GOES 16 had kind of a weak one. Since then, things have been a little bit more normalized, seeing a little bit higher lows and lower highs on the GOES magnetometers. And let's take a look at the solar cycle. So the Earth is currently in a North Pole-oriented current sheet. You can see that demonstrated in the green lines there. Those are the potential field surface source lines of plasma that is North Pole plasma. The South Pole plasma there, mostly on the opposite side of the sun, depicted in red. And here's why there's a long way to go to get to solar maximum. So you can see most of the South Pole magnetism has left the south heliographic polar region, right? So you see these lines here, these red lines. It's like not solid red. That means it's at the opposite pole. You can see a little bit of red still there at the opposite pole, which is fine. However, there's quite a bit of green at the North Pole. So you see these large blobs of green there. That is north heliographic polar magnetism. Those need to leave the North Pole and vice versa for the South Pole before we reach solar maximum. So at the moment, not there yet. Here's our line of sight field plot. The sun's B field depicted in blue. And again, Earth is solidly in a North Pole current sheet. No apparent sudden changes coming. Just keep in mind the magnetic environment can suddenly change with zero warning. So here's our line of sight coronal hole plot. And you can actually see some migration there. So if you look down here, you'll see actually some South Pole magnetism creeping up toward the equator. So that's a great example there. South Pole magnetism taking a move there. So that is a progression of the solar cycle there, as the North Pole has to make it to the south and vice versa. And that is what a solar cycle is. The magnetic field reversal process, as well as, of course, the increase in sunspots. So that's coronal holes. Here's a view in 211 angstroms plus 171. And so this coronal hole down here, that is South Pole oriented. This is North Pole, and this is also North Pole oriented coronal hole. This one here quite well defined there. And let's move to sunspots. I'll let that play through one more time for your viewing pleasure. Number 1, I encourage you to not take a number 2 in your pants. Engage. So here's our sunspot viewer. And yeah, a reduction in sunspots since yesterday. We've seen lots of sunspots evaporate here. This one up here, that's just a plage, not a sunspot yet. There is likely one rising down here in the southeast. Let's take a look at sunspots over the past 24. There's 171 plus SDO continuum. Here we'll zoom in a little bit closer. And we include 171 angstroms here to show the most active regions. And here we've subtracted 171 angstroms to give you the most detail of sunspots. So sunspot number here dropped again. Also radio flux expected to be even lower unless some additional sunspots suddenly form. At the moment, things have been weakening, which will probably cause people to buy all the rice at Walmart, dig their bunker a little bit deeper, and believe all kinds of nonsense that they're hearing on YouTube about grand solar minima, a thing that is clearly not occurring. Let's continue to energetic particles and solar flares. Don't get them confused. Protons are the primary product of a coronal mass ejection. Yeah, protons. And photons are what a solar flare is. Photons are solar flares, and coronal mass ejections are protons. Now, these particular protons, these are the relativistic type that typically show up after major solar flares. We've only got a little bit up there circling around the probably mostly the polar L shells of planet Earth's magnetic field. It's subsided here, so no big spikes in the proton flux there and no major flares, just one or two little tiny C-class intensifications since yesterday. Here's a wavelength that'll show flares. That's 131 angstroms plus 171 angstroms. And that C-class flare came from, I think it came from this rising active region down here, actually. Let us know in the comments if you agree, disagree, or have a different idea. Not sure where that C-class flare came from, and it's tiny anyway, so let's move on. I think we've shown you some pretty fresh imagery. What would you say? Next, looking at what's going on overhead, and the moon is in Sagittarius. So that means something to someone. Maybe we're mooning the galaxy at this point. I'm not sure. Yeah, so the moon is in Sagittarius, which make sure you update your astrological chart to reflect that, whatever that means. You've also got Saturn and Mercury. Mercury very close to the sun here. And you'll see Jupiter and Venus rise behind it. Here's our solar system forecast. Let's move this forward 1 week. There's where things will be in a week on March 23rd. Next, we'll look at coronagraphs now that we've oriented you as to where objects are in the solar system. And here are yesterday's coronagraphs, the Ides of March. Yes, the Ides of March, the day that 3 years ago we had an apparently engineered financial collapse. Let us know in the comments if you have theories about why institutional investors would intentionally create a financial collapse. Anyway, that's yesterday's coronagraphs, not very exciting. Here are today's coronagraphs, also not very exciting. Let's see what's going on from Stereo A and the Soho Lasco C3. Please pay attention to the time and date stamps. Those are at the bottom of your screen there. And coronal mass ejections here have been quite light, almost non-existent in the past 24 hours. That didn't stop us from creating some 24-hour videos about it, though. So here is the past 24 hours featuring Mercury there, sliding from the Soho Lasco C3 to the Soho Lasco C2. Here's an even better view of that. You can see the differences in contrast and resolution there between the C3 and C2. And we'll get in a little bit closer here. Again, those are 24-hour videos. It makes it easy for us to do the daily space weather. Anyway, next we'll look at filaments, and we've got some quite significant filaments, especially this crown prominence up here. So, I mean, that one could use a name, I would say. I don't remember what the names of these filaments are, but if you'd like to name filaments, make sure you join us over on Twitter. So we're all over the internet at Smashomash. You can find links at the homepage at smashomash.com. Make sure you follow the hashtag NameThatFilament and hashtag SpaceWeather on Twitter. So you're invited to name that filament. Here's the past 24 hours and 171 angstroms all by itself. As we see declining solar activity, oh no, the world is going to be plunged into darkness. Pardon my sarcasm. When fearmongers clash, coming later in the video. So here's the past about 2.5 hours, and there's actually a CME happening as we speak. Right adjacent to this South Pole-oriented coronal hole down here, we see a filamentary eruption, and some of it looks like it's collapsing also. So a likely CME there. Maybe it all splashed back down. If it's anything super exciting, we'll totally make another video later today. And I'm glad to hear Mike Bordages finally realizes that Twitter is completely broken. Next, looking at our Space Weather Enthusiast dashboard, our satellites community dashboard, rather, to see no charging hazards here. It's smooth sailing for satellites. Let's take a look at some other satellite-based data here. Here are the GOES electron flux. That's the GOES 16 and GOES 18's radiographic measurements. And you're seeing a cratering here of the electron flux, typical of coronal hole high-speed streams and coronal mass ejection impacts, both of which we've seen in the past 24 hours. The GOES 16 and GOES 18, they measure that at the F layer of the ionosphere, which will show you here major anomalies continue up there. And here is your relativistic electron forecast model. So we got a little bit lower levels than even expected by NOAA there. I considered forecasting lower levels, but I didn't. So anyway, that's the forecast. The green boxes are the forecast. The yellow diamonds are the observation. There's the 1-year graph to put it in context, and reaching very low levels here as that coronal mass ejection impact strikes. Again, those electrons, the greater than 2 mega electron volt electron flux, is measured at the F layer of the ionosphere using radiography from the much, much higher geosynchronous near equatorial orbit of the GOES 16 and GOES 18. So here's the vibrational frequency of that bridge between Earth and space, the F layer of the ionosphere. So significant anomalies continue, not quite as extreme as yesterday, but still significant anomalies. And if you're not familiar with looking at the raw vibrational frequency imagery, not to worry. We'll show you the anomaly gram as well. And there is the anomaly gram. That's anomaly in megahertz from a 30-day median. And you see some rapid swings there from low to high frequency anomaly. Low frequency anomaly shown in red, high frequency in blue. Keep in mind that March is the most geomagnetically active month on the planet. It all has to do with the angle of attack of incoming solar wind, the acceleration of relativistic electrons in the outer Van Allen belt, an effect called the Russell-McFerrin effect. So that's why the equinoxes are more geomagnetically active than the times around the solstices. Anyway, that's what's going on. Major ionospheric anomalies happening here. Rapid swings, especially around the Atlantic Ocean and the South Atlantic anomaly, which is right here, situated back over the South American continent. Here's the latest image we've got. That's 1145 universal time ionogram. That's megahertz, millions of vibrations per second. And that is the anomaly gram. Keep in mind that does show 10 times higher resolution. It's part of the reason why we show it. It shows down to 1/10 of a megahertz in anomaly. So that's the current situation. We'll also show the total electron content forecast. That's the free electrons all the way from the inner portion of the outer Van Allen belt down to your handset, a run of about 12,500 miles. And it's actually very organized here. So that's a little surprising, seeing such low levels of electron flux and such high levels of organization. So GPS errors here are actually quite normal, despite major scintillation in the ionosphere. So those are the most likely places to see GPS errors, your total electron content forecast, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And let's move on to the to the consistently full of crap about space weather channels, Oppenheimer Ranch Project, and suspicious observers. So I noticed a tweet this morning where Oppenheimer Ranch Project says Ben Davidson is selling fear, not facts. And then I go to Oppenheimer Ranch Project's YouTube page, and guess what? Under, quote, grand solar minimum resources, end quote, guess what channel's featured? Suspicious observers. Little bit inconsistent there, Diamond. You are consistently full of crap about space weather. You should stick to geology and botany. Next, if you want to become a member of the Smash team, consider supporting the channel that way at smashomash.com/Smash team. It's the official subscription services site. We are still on Patreon. You can still drop us one-time donations on PayPal. Also visit our links to find the Hemp Lucid shop. And if you're shopping on Hemp Lucid right now, make sure you enter the promo code SMASHOMASH to save some dough on checkout. You can find all the links at smashomash.com, our homepage, and welcome to the Neo Renaissance. Again, congratulations on realizing the channel exists. Look for ongoing changes coming to the websites and so forth. And hit us up on your favorite social media. There's also a permanent invite link to the Discord chat, to the Hemp Lucid, Twitter, Instagram, etc. Thanks to everybody who's supported the channel low the past pushing 6 years. And here are our latest solar images. And we do see a magnetic field rising there. It's going to be too early to see any ombre. This active region up here is a plage, not a sunspot. There is the rock back. Significant decline in solar activity once again since yesterday. And if that frightens you, I feel sorry for you. There is a lot of additional activity to come between now and solar maximum, which we are not at, by the way. Also, we will be streaming live for the equinox. So the equinox occurs at 5:24 and 20 seconds p.m. Eastern Time. That's Eastern Daylight Time for Lehigh Valley. You've only got 4 days of winter left. What are you up to? We'll be streaming live on YouTube starting at about 5 p.m. Eastern Daylight Time on Monday, March 20th. So make sure you join us for that. Our equinox stream, it is a regular feature of the channel. And let's move to the realm of meteorology. So what we're looking at here is the ultraviolet index and erythemal dose rate. That's like how red your skin will turn as a result of sunburn, basically. And if you're wondering why are all these spots here? Why is the UV way lower there than all those other areas? And the reason is because of clouds. Yeah, clouds. When it's cloudy, you don't get as high of a UV index or erythemal rate. Very thick clouds, they create shade. And that's why you see these breaks in the UV index. Now, we are showing this because you can see the sun's rays are about to be perpendicular to the planet. That's what an equinox is. It's when the sun's equinox crosses the Earth's, when the sun's equator, rather, crosses the Earth's equator. That's what the equinox actually is. And let's move to our regularly scheduled meteorology products here. We don't want the video to be too lengthy. So these are the surface winds of the eastern world. And these are the jet streams. Now, if you had only one weather feature to forecast global weather patterns, highly recommend you use the jet stream. Powerful anticyclone here over northeastern Australia. You can see that counterclockwise rotation, a prime example of an upper-level high-pressure zone. Those are going to rotate counterclockwise in the southern hemisphere and clockwise in the northern hemisphere. Here are the jet streams of the west. Some large bends, and a portion of North America features a tripled-up jet stream, and then a convergence over the western Atlantic. Here are the surface winds of this side of the planet. Two large low pressures there in the northern Atlantic. Lingering off the coast of Cape Cod is one of them, as was forecasted. Here are the surface winds of the central world. And down here, we've got an upper-level high-pressure system there. You see that clockwise rotation there? That's the surface wind scenario. And there is the jet stream scenario. There is a large kink there where you've got high pressure in between Africa and Antarctica. Anyway, that's the jet stream scenario for the central world. And next we're going to look at clouds and fog over the Pacific. Yeah, I got bored of looking at clouds and fog every day over the Americas, so today we're going to look at clouds and fog over Earth's largest heat sink. Yeah, the largest heat sink. Why are hot water heaters used as hot water heaters? Because water has a very high heat latency. In other words, it takes a lot of energy to heat up water. It also consumes a lot of energy to cool down water. So, in any case, That, my friends, is the world's largest surface heat sink, the Pacific Ocean. Did you know that Earth's heat latency lies in the oceans, not in the atmosphere? What does that mean? That means you can measure the atmosphere all day long and not have any idea, at least any rational idea, of what Earth's climate is. What's the temperature? Well, in order to really tell the temperature of the planet, you need to measure the water in the deep oceans. There's a lot of it, and it's holding a lot of heat. If you think mankind is able to heat up and cool down the oceans, you need to take physics. Continuing on to our weather.gov map. Weather.gov, click your location. If your location is lit, we got some hard freeze warnings in the southeast. We've scrolled down to show you the key. That's about all we can do. Besides say, hey, watch out for avalanches. There are some avalanche warnings there showing up as well. Weather.gov is the location. Let's show some forecasts. Here's a temperature anomaly forecast in degrees Celsius for the next 72 hours based on the GFS model. We'll also show pressure and precipitation. That's the same model, the GFS, 72 hours. And we'll also show total accumulated precipitation in inches. There's where the precipitation likely to be occurring based on the GFS model. And we'll also show new snow based on the Euro and GFS model. So there's the GFS model for new snow for the next 3 days, and there's the Euro model for new snow for the next 3 days. And let's move on to see where lightning's been striking. So there's the past about 10 hours. That is some significant lightning there in Arizona and New Mexico. Besides that, pretty quiet over the U.S., a little bit of lightning there striking Texas. Here's an interesting one. We had a meridional line here where there was lightning all the way from Honduras down to the Galapagos. And since then, that has subsided. But a bunch of lightning occurring there in an interesting, nearly perfectly vertical line. So a band of lightning there stretching from north to south. It is now gone, but there's where your current strikes are. That is lightningmaps.org, by the way. Next time you hear thunder, check it out. We did actually have a strike there in the central U.S., it looks like. One strike near Hannibal. Anyway, there's the full view. We'll also show U.S. Doppler radar. I realized forecasting the weather was a little bit too easy about 15 years ago. And now here we are, taking on a little bigger challenge, explaining the solar sunspot cycles. Here's shortwave radiation showing clouds and fog. Great view of that low pressure there, which is finally starting to move a little bit. It's actually moving to the southeast. And there is the water vapor map. A bunch of moisture there from New Mexico to Lake Superior, which is actually going to be kind of pushed back down to the south a little bit there, as there is some cold air blowing in from Canada. Anyway, here's your recap to close things out. Vertical motion of water droplets and ice crystals via ground-based Doppler radar systems. Satellite-based 3.9 nanometer infrared radiation, which shows clouds and fog. And perhaps the most definitive of all, the water vapor map. It shows all the water vapor, not just clouds. It shows dry areas and moist areas. Hopefully that helps. Thanks again for tuning into the Smash News Network, least busted name in news. May that solar wind be at your back and that nonsense absent from your YouTube feed. Also, don't forget to visit the links here and here and here.